All right, guys, we are back for week 6. This is going to be just a continuation, pretty much, of last week, which was week 5. So I'm going to make it pretty short this week, pretty simple, because it's just picking up where we left off. So this is the same paper I was working with last week, and these were the last 2 examples from week 5's notes. So I'm just going to go on to the next section. And obviously I'll explain what we're doing here. It's not that different. But I did want to remind you guys just of a couple things. One of those being that I had to submit interims 2 days ago on Friday. Now, they're not, they meaning the school. The school is not going to print those interims and get them out to you until tomorrow. So really, tonight is the last time I can make any potential changes to your interim grade. Now, what I've been seeing a lot of is people turning in just homeworks and not the notes. So that's part of the reason why I made the rule of, late homework. If you submit the homework after the answer key was posted, and that was just new this week, okay? If you submit any homeworks after the answer keys have been posted, you're only going to get half credit, because I can't differentiate between who just waited for the answer key to come out and copied from it and who actually, just did the homework, did the problems, but maybe didn't show any work. I need to see the notes, guys, before I give you a grade for the homework. So if you are just copying down the answers from the answer keys and turning in homeworks, I'm not giving you grades for those until I see the notes. So that's reminder number 2. Okay, reminder number 1 was interims are in. So if you want anything put in for that interim grade, it's got to be tonight, meaning Sunday. So maybe Monday morning, tomorrow morning at the latest, but I'm not going to be up all night putting grades in. So anyways, reminder number 2 was, the late homework thing. You guys have got to get me your homeworks before the answer key is posted, because I know some people are just using those answer keys to copy answers and get the homework done that way. So I can't give you a grade for that until I see the notes. And then reminder number 3, I guess, is just to make sure you're putting your name on everything, notes and homework, just so I can see it's your work and that you're getting both of those to me for a grade. So that's the other reason why I can't just get notes or I can't just get homework. You're not going to get full credit for everything. I need both. So I need you to take the notes and then complete the assignment. And that's all we've been doing week to week. So I think it's very manageable to do a set of notes and then 1 homework over the span of 3 or 4 days. I think that's very doable. I know you guys probably have other stuff going on, and we're probably, some people are actually getting busier being stuck at home. Maybe you guys found jobs. But anyways, I need those turned in before the answer keys are put out. So enough with the reminders. Let's finish up these notes from last week, which the only difference is going to be that now we're going to look for a greatest common factor first, and then we're going to work with the difference of squares. So last week we did these types of problems where we had a rule to follow and it was for the difference of squares. So you have to start with a subtraction sign. Okay, we found out that if there's an addition sign, it's going to be a prime answer, because there's no way to factor that out using the difference of square rules. So we have to have that minus sign in the polynomial, and then we're going to split it up into those 2 sets of parentheses, one with a plus sign, one with a minus sign. And basically you're just looking for what you would multiply times itself to get what you started with. Okay, so these are the examples we did last week, and our examples this week are going to have us pull out a greatest common factor from the terms. So what we're looking for with the greatest common factor, just to remind you, is we are looking for something that can go into both our first and second term. Okay, whether it's just a number, whether it's numbers and letters, it has to go into both, and we're going to pull out that lowest. I mean, it's the lowest thing that can go into both, but it's going to be the greatest common factor. We're going to pull that out and put it in the front. Okay, and then we're going to see what we would need to multiply, what would be remaining to get what we started with. Okay, so basically we're kind of pulling from the last 2 weeks of notes, because the last week, like I said, was difference of squares, and before that was greatest common factor. So we're putting those two things together. Okay, so looking at 2n squared minus 72. Well, we don't have a difference of squares yet. So we do have a subtraction sign. That's a good start, but there is a common factor that I can pull out of 2n squared and 72. So both of these terms are actually divisible by 2. That's the biggest number that will go into both. Now I can't pull out an n because 72 does not have an n after it. So all I can pull out is a 2. Okay, what would I need to multiply 2 by to get 2n squared? Well, that would be the n squared. Okay, now to get the minus 72, well, what would you need to multiply the number 2 by to get a negative 72 or a minus 72? Well, it's going to have to be minus something. It's going to have to be a negative number if I want the result to be negative. So what times 2 is 72? That's 36. Okay, so now we have, even though we had to pull out a greatest common factor, now we have a difference of squares. We have a subtraction sign in the middle, and then we have two terms that can have a square root taken out of it. So we're going to keep our 2 out front, and then I'm going to have my 2 sets of parentheses, and I'm going to put the plus sign in one of them. I'm going to write this one a little bigger, and the minus sign in the next one. Okay, so what we put in the beginning is how we're going to multiply together to get n squared. Well, what times what equals n squared? Well, that's n, because remember, when we're multiplying with exponents, we're going to imagine there's an invisible 1. This would have an exponent of 1. And when you multiply with exponents, you add them. So n times n gives you n squared, because 1 plus 1 equals 2. Okay, now what's the square root of 36? That's 6. So this is what we did last week with difference of squares. We had a plus sign and a minus sign, and we took the square root of our two terms. Now our greatest common factor just stays out front because it was part of how we got to our difference of squares. Okay, so this is the answer to number 21. And I just circled the ones we're going to do just to keep these notes short. We're not going to go through all the examples that I have on my paper. But the next one we're going to do here is, right next to it, is 22. All right, so look for our greatest common factor first, then factor the remaining difference of squares. Okay, you can always double check your work by distributing. We could distribute our greatest common factor and then multiply our 2 sets of parentheses together. Okay, greatest common factor. We can take out a number from these two terms here. They're both even. Okay, they're both going to be divisible by 2, and that's going to be our greatest common factor, actually. There's nothing bigger than 2 that's going to go into both 18 and 50. So again, I'm going to take out the number 2. If this 50 had an x after it, we could pull out the variable x, but they have to have the number or the variable in common in order to remove it for the greatest common factor. So let's see what we have left. All right, what do we have to multiply 2 by to get these terms that we started with? Well, to get 18x squared from multiplying by 2, you need to multiply it by 9x squared. Okay, 2 times 9x squared gives you 18x squared. Got to have a minus sign in the middle because 2 times something has to give us negative 50. So 2 times a negative number will do that, and that negative number is 25. Okay, so now since we've pulled out a greatest common factor, we have a difference of squares. We've got a minus sign in the middle, and we've got two numbers that we can take the square root of. So I'm going to keep the 2 out front, and I'm going to make my 2 sets of parentheses, one of them with a plus sign and one of them with a minus sign. So what we're trying to take the square root of is this 9x squared. Okay, what times itself would get us 9x squared? Well, that's just going to be 3x. So I'm going to put that term in the front of both sets of parentheses because 3 times 3 is 9. X times x is x squared. And then the square root of 25 is just 5. Okay, so our final answer here, after taking out a greatest common factor and then using our difference of squares rule, is 2 times 3x plus 5 times 3x minus 5. Okay, so let's go down here. We got 3 more that I want to do, and they're numbered 25, 26, and 27, but you can number them however you like. All right, what do we got with 25? We do have a little bit more variables here. We've got some even numbers again. So what can we take out of 24a squared and negative 54b squared. Well, these aren't the same letter, so I can't pull out a variable as part of my greatest common factor, but I can pull out a number. Now, the biggest number that's going to go into both 24 and 54 is the number 6. Okay, so let's write what we have remaining in parentheses. So 6 times what would give me 24a squared, and that would be 4a squared. Okay, we've got to have the a squared in here somewhere since I did not take out any letters with the number 6. Okay, we want to have a negative number next, so I'm going to have to multiply 6 times negative something, and that negative something is 9b squared. Okay, so we do have our difference of squares. We've got numbers that we can take square roots of, and we have a minus sign in the middle, so we are good to go. So let's put our 6 out front. Let's make our difference of squares rule with a plus sign and a minus sign. So the square root of 4a squared would just be 2a. Okay, 2a times 2a is going to give us back our 4a squared. 2 times 2 is 4. A times a is a squared because we add our exponents. Same thing with 9b squared. What number times itself is going to give us 9? And we know probably already that b times b will give us b squared. So that number we're looking for is a 3. So 3b times 3b will give us that 9b squared. So our final answer is right here. Okay, so the only thing we're doing differently from last week is we're pulling out our greatest common factor before we use our difference of squares rule. All right, number 26. It looks like we're working with the same letter, which is the letter B, in both of our terms. So when we're pulling out our greatest common factor, we're going to take out a variable, a letter, along with a number. Now, when we're taking out a variable, we have to look at the exponents. Okay, yes, they both have the letter B, but what's the smallest number that we can take out? Okay. The number, let's start with the number, and then we'll take out our letter B. Now, the biggest number that's going to go into both 136 is the number 4. Okay, but this is what I mentioned earlier with looking at the smallest thing that can be removed from both. And the letter B, I'll write this up here. We've got a B cubed and a B. So that letter B has an imaginary exponent of 1. Okay, well, what's the biggest thing, or you could look at it as what's the smallest we can take from both? The smallest amount of b that we can take from both is just one of them, because even though this b is raised to the power of 3, this one's only raised to the power of 1. So I can't take 2 or 3 away from this. It doesn't have that much to give. So the smallest I can take is just a b to the first power. So I'm going to put that b after the 4. Now, to get what we started with, I'm going to make one set of parentheses and see what we would multiply 4b by. So 4 times what number gives us 100? Well, that's 25. Okay, if this is b to the first power, what plus 1 would get you 3? Because remember, we're adding exponents when we're multiplying them. So 1 plus 2 would give us the 3 that's in our original term. Okay, and then the next number we're working with is a negative, so I need a minus sign there. 4 times negative something will give me negative 36. Now that number is 9. So let's see if we need to put a letter B after the 9. We want to end up with a negative 36b. Okay, just b to the first power. So 9 times 4 would give us that 36, and then b would still be after it. So we would end up with 36b. We don't have to write any b after this because this isn't b squared. It's just b to the first power. So now we've got our difference of squares. So I'm going to keep the 4b, my greatest common factor, out front and make those 2 sets of parentheses. Okay, square root of 25 is 5, but we need to make it a 5b. Oops, I forgot my plus and my minus. We need to make it a 5b in the front because b times b would give us the b squared, and the 5 times 5 would give us the 25. So the square root of 9, this last part's easy, is just going to be a 3. So our final answer for number 26 is everything I circled right there. And our last one is going to be number 27. So I'm not going to break down every step here. I'm just going to kind of write it down. And if you need to pause and catch up or rewind, just, do that on your Chromebook or whatever you're using. So I see after the 80 and the 125, it looks like the greatest common factor is just going to be a 5. Okay, now we've got an n to the 4th and an n squared, so it looks like I can take out, at most, n squared from both of them. Okay, so I'm going to make my parentheses to get back to what we started. 5 times, I think that's 16, is going to give me 80. Now to get n to the 4th, I'm going to have to add 2 to the n squared that's already there. So when we're multiplying, we're going to want to have another n squared there. Now what times 5 is going to give me 125? Well, that's a negative 125, so I want a 25 there. Now I don't need to write any n after that 25 because it's already an n squared, and that's what we have in the problem. So let's factor out this difference of squared. 5n squared out front, plus sign, minus sign. The square root of 16n squared is just 4n, and the square root of 25 is 5. Okay, so here's our final answer. Again, only difference being we have a greatest common factor to take out initially, because right now in the problem that you're given, all the problems that you've been given, you don't have a difference of square problem yet. You can't take the square root of 80 and the square root of 125. You need to take out the greatest common factor first to get to this difference of squares that you can actually take the square root of. So look for that greatest common factor in your homework and then use the difference of squares rule.